Hi everyone, Ali here with a new prompt engineering technique called chain of thought prompting. Let's see what it's about. As a kid, all of us have a tendency to provide a knee-jerk answer if asked a complicated question, especially if we feel we may have a shot at our answer being the correct one. After all, who wants to go through all the trouble of computing all the way and thinking through the solution if we feel pretty confident in our guess to be correct answer? Worth a shot, right? Turns out, large language models are not too different in this behavior. In our ChatGPT features and prompt engineering series, we have multiple times come across this issue that when it comes to mathematical or logical or reasoning kind of questions, large language models, at least today, suck. They would generate a totally wrong answer confidently and may even provide a small explanation for that wrong answer too. But that would be totally wrong, just like a child. What kind of behavior is that? The model should be sent to detention for doing that repeatedly. The problem with humans and model alike is that when it comes to mathematical and logical questions, not taking shortcuts via guesswork is often costly. The first instinct of humans and models would be to save brain and processor usage and try to guess an answer, especially if it feels correct. But many a times, just like you may have experienced, the teachers would not give you a good score if you just write the answers and don't write the steps or reasoning for coming up with that answer. Even as adults, during interviews, trick questions are used to see the approach of a candidate. Lead code is filled with such problems where guesswork and jumping to conclusions simply destroys you. One of my favorites used to be to tell an angle between two hands of an analog clock at 3:15. Most people will instinctively start by saying 0. When forced to come up with the steps or reasoning, your accuracy improves dramatically, I hope. Turns out, and very counterintuitively, the same is true for most large language models. If you come to think of it, it makes sense. Large language models are predictive models. They are just trying to come up with the most plausible response to your prompt. If their training included a question similar in nature to the one you are asking, they might try answering with its answer first. Don't expect a large language model to be trying hard to come up with the most accurate response to your query. It would try the most plausible answer first. But being aware of this limitation of the large language models give you certain prompt engineering techniques to elicit a better quality output. Some were covered in our prompt pattern series, yet probably the best of such type of techniques is chain of thought prompting. Content of this video is very much inspired by an amazing paper from Google Research Brain team comprising of Jason Wei and colleagues. I have provided link to the actual paper in the description and would highly encourage you to read it since we are obviously not going to go in full detail. The video is trying to simplify the detailed information in that paper. One information lesson from the paper is that the technique is subjective with respect to the size of the model in question. The larger the model, the more effective the technique is. But still, the technique works in most cases and shows marked improvement in large models. There are tons of example prompts and their output for various large language models given near the end of the paper, which you can use to improve your skills of this technique. This is it about the paper. Let's continue with chain of thought prompting. So the main idea of that technique is that forcing large language models to demonstrate that its output is based on reasoning forces it to process your question more and in doing so, refining the answer. It also makes it break down the problem into coherent, intermediate constituent steps in most cases, especially where it is required. Note it is a complete reversal of few shots, where we provide examples of solving problems with intermediate steps and model follows, while here we are asking it to come up with or generate intermediate steps. As we discussed earlier, the model would always try to reduce processing where it can, and chain of thought prompting forces it to process your answer more than it would do by default. Right reasoning leads to right answer, and getting step 1 correct leads to better chances of steps 2 being correct, and so on. Easiest way to visualize it is dividing a large number by a small one manually. It needs to be done step by step, and all steps are important to get the right answer. It's just a basic example if we are talking complex logic and reasoning based questions here in context of the prompt engineering technique. Experiments on multiple large language models show that chain of thought prompting improves performance on a range of arithmetic, common sense, and symbolic reasoning tasks. It is applicable to any task that humans can solve via language. The empirical gains can be striking. Can we consider chain of thought prompting to be forcing model to overthink? Well, in some situations, yes. It might have responded correctly without chain of thought, but what about the situations where it should have and didn't? And how do you know if it did think or reason when it should have? There is no visible red line, and hence for any complex question, and without chain of thought, someone has to do the hard work of fact checking the answer. So it's either you or the model doing the thinking. If you're happy to do so, you can get the model off the hook. Otherwise, chain of thought is your friend. Another important aspect is that chain of thought prompting provides an interpretable window into the behavior of the model, suggesting how it might have arrived at a particular answer and providing opportunities to debug where the reasoning path went wrong. Although fully characterizing models' computations that support an answer remains an open question, you can identify and change the prompt or question or add further details to reduce chances of confusion and nudging the model to the right answer. At least you have a shot. The technique can be effectively combined with few shots prompting technique, which we covered in earlier video on this channel, where you give it a few examples and provide detailed reasoning in the answers. The examples, coupled with explicit instructions to rationalize the output, makes for a detailed and hopefully more accurate answer. Just few shots prompting with question and answer would result in more erroneous answers than when our examples involve a reasoning section where we provide a reasoning for our answers. The answer might actually change and hopefully for the better. Right, finally, we are going to go over some examples, starting off with the wrong ones. I have listed one of multiple categories of errors, so apologies for the small print. For sake of time, I won't go through all the examples, but you can pause and take a look. Or better still, find examples in the paper link below to see more examples with full details of errors and incorrect versus correct reasoning. Most errors large language model make with these kind of questions can be broadly categorized in three categories. These are calculator errors, semantic understanding or symbolic mapping errors, and one-step missing errors. Calculator errors are simple errors arising out of incorrect calculation. You can see the first example where a very simple multiplication has an error, where instead of 600, it calculated 300 for the very simple math equation. The study showed 8% chain of thought prompts were correct except for this type of error. The other category is semantic understanding or symbol mapping kind of errors where model makes an understanding on mapping error. And lastly is one step missing error where the steps required for a correct solution have some missing step. This is the biggest contributor to errors with 22% in the study compared to 8% of calculator and 16% in symbol mapping errors. Right, all is not doom and gloom. There are some right examples. So, as you can see, we can go over one of them. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? Right. As you can see, the large language model correctly came up with a reasoning and the correct answer in both of the cases for this example and the next. All right, let's move on to next slide. You can pause the video and have a look at these examples. And again, there are more in the paper link below. All right, so why did this happen? Consider one's own thought process when solving a complicated reasoning task such as multi-step math word problem. It's typical to decompose the problem into intermediate steps and solve each before giving the final answer. Forcing the model to generate a similar chain of thought makes it dive more deeply as it has to come up with reasoning for each step. Note that change of thought prompting does not give best results on smaller large language models and works best with models of 100 billion parameters or more. Those smaller models do generate chain of thought fluently, but it might be illogical, leading to wrong or incorrect answers. Right, so there are two main conclusions from the study that while the technique is applicable to any text to text task, it works best for tasks that are challenging and requires multi step reasoning, and a large language model is used. For problems requiring single or two steps only, the performance of even smaller models are pretty good, and using the technique is an overkill, achieving little additional benefit. Right, picking just one example from the paper, Tracy used a piece of wire 4 feet long to support tomato plants in the garden. The wire was cut into pieces 6 inches long. How many pieces did she obtain? And answer by model with 62 billion parameters. She cut the wire into 6-inch pieces. This means she got 4 by 6 is equal to 24 pieces. The answer is 24, which is incorrect as the model made a semantic understanding error. But compare this with an answer by model with 520 billion parameters. The wire was 4 feet long. This means it was 4 into 12 equal to 48 inches long. It was cut into pieces 6 inches long. This means she obtained 48 by 6 equal to 8 pieces. The answer is 8, which is correct. So you see, the same prompt got two different answers, and the one from the large language model was correct. Many more examples in the paper. Like showing you a result slide from the study where various large language models and their size variants were subjected to benchmark tests. Take home being that it is better be used with large variants of large language models for problems requiring more than two intermediate steps. Read end of paper for host of examples of chain of thought prompting. Alright, this is it for the chain of thought prompt engineering technique. If you liked, please like and share and subscribe to be notified of exciting content like this one. Thank you.